Imagine shrinking down to a size smaller than the smallest atom. This is the quantum realm, where the rules of classical physics no longer apply. Here, particles behave in strange and counterintuitive ways, defying our everyday experiences. Quantum physics is the study of this bizarre and fascinating world, a realm that governs the behavior of matter and energy at their most fundamental levels. For centuries, classical physics reigned supreme, explaining the motion of planets and the behavior of everyday objects. But as scientists probed deeper into the atom's heart, they encountered phenomena that classical physics couldn't explain. It was like trying to fit square pegs into round holes. A new set of rules was needed, a new understanding of reality itself. This is where quantum physics steps in, offering a revolutionary perspective that has transformed our understanding of the universe. It's a world where particles can be in multiple places at once, where information can travel instantly across vast distances, and where the very act of observation influences the outcome of events. Welcome to the quantum revolution, a journey into the heart of reality that promises to reshape our world in unimaginable ways. Don't miss out on more mind-bending quantum physics insights. Subscribe now and join the quantum revolution. One of the most mind-bending concepts in quantum physics is wave-particle duality. It tells us that light, which we often perceive as a wave, can also behave like a particle. This dual nature of light, behaving as both wave and particle, was a revolutionary discovery that shook the foundations of classical physics. Imagine a beam of light passing through two slits. If light were purely a wave, we'd expect to see two bright bands on a screen behind the slits. But that's not what happens. Instead, we see an interference pattern, a series of bright and dark bands, indicating that the light waves have interfered with each other. Now, let's dim the light source until only one photon, a single particle of light, is emitted at a time. If we repeat the experiment, we'd expect each photon to pass through one slit or the other, creating two bright spots on the screen. Surprisingly, that's not what happens. Instead, the interference pattern gradually emerges, even though each photon acts individually. This astonishing result demonstrates that light, even when acting as a single particle, also behaves like a wave, interfering with itself as it passes through both slits simultaneously. This duality, this ability to exist as both wave and particle, is a fundamental property of not just light but of all matter, including electrons and even entire atoms. Another mind-boggling concept in quantum physics is superposition, the idea that a quantum particle can exist in multiple states at once. This is like saying a coin can be both heads and tails simultaneously until we actually look at it. Imagine a single electron orbiting an atom's nucleus. In the quantum world, the electron doesn't follow a well-defined path like a planet orbiting the sun. Instead, it exists in a cloud of possibilities, a superposition of all possible positions and energies. It's like saying the electron is both here and there, spinning both clockwise and counterclockwise, all at the same time. This might seem counterintuitive, but that's the strange reality of the quantum world. The act of measurement forces the electron to choose one specific state. Before we measure its position, for example, the electron exists in a superposition of all possible locations. But the moment we measure it, the superposition collapses, and the electron snaps into a definite position. This inherent uncertainty, where particles exist in a haze of probabilities until measured, is a fundamental aspect of quantum mechanics, challenging our classical intuitions about the definiteness of reality.